Hey everyone, welcome back to SAP Learning Studio. I am Alex Souza, and in this video we are going to dive into something really practical, how to implement internal early numbering in SAP RAP the right way. Now if you have been following along with the series, you have already built a sales order app and created a number range object in our previous video. If you haven't watched those videos yet, links are in the description. Go check them out first and then come back here. So one of the most important thing before we start in the video is we are going to do it properly with full number range integration, proper error handling, and I'll also show you a critical configuration step that most of the tutorials skip, and that skip will cause your app to crash. So stay with me till the end. So all right, let's begin. So the first thing is the configuration part. In our previous video, if you remember, we had created a number range object. So we have a number range object and we need to configure it first. So the step everyone forgets. So we need to configure this particular app. So before writing any single line of code, there is a configuration needed for this, and which is very mandatory. And find your number range object under number range objects. For our number range object, that is ZNU underscore range, and we have to select the buffering. By default, if you see, there is no buffering and the buffering is off, so we have to set it as main memory buffering, and buffered numbers we have to give it as 10. We have to check and we'll activate this. So why this matters is, while buffering is off, SAP number range runtime executes a direct update statement on the primary database connection. And in RAP applications, your early numbering method runs during the interaction phase, and the DB update on the primary connections are strictly forbidden. And your app can crash if this is off, and it will cause you an drum. So when buffering is on, SAP switches to the secondary database connection, and which is fully permitted during the interaction phase. So buffering on always, do this first. And now let's move to our app. So if you remember, we had created a order application, sales order application, and when we click on create, we used to manually enter the order ID. So this we are going to automate using our number range object. So the number range object will create the order ID automatically. So the next step is to open our behavior definition. So let's go to our behavior definition. So this is our behavior definition, and we need to declare that our business object uses internal numbering. This tells the RAP framework that assign unique ID to every new record before it gets saved to the database. So we have to add early numbering over here. So just add early numbering and this statement in your behavior definition. So this will help it understand you are using early numbering. And one more important step is we are going to keep our order ID as read only. So when we keep this order ID as read only, it will show us that the order ID is read only, and since we are going to use this early numbering, we will generate the number automatically. So now let's activate this. Once this is activated, we have to go to our class, and this is an auto generated class. So let's go to the class, and I have a code snippet already. I'll just paste it and I'll explain you line by line what this class does. So under the local classes, I have pasted my code, and let's activate the class. So here we have a method called as early numbering create, and if you press F2 on it, so just place your cursor and press F2 on it to open the ABAP element info, and this will show you the full method signature, all the importing and all the exporting parameters, all the changing parameters. So I'll just give a quick summary of what we are working with. So we have entities. So this entities, I can click on this and I can go inside as well. So this entities is the list of record that needs an ID to be assigned. The next thing we have is mapped in the changing parameters. So this map, this we confirm to have the framework which ID was assigned to which record. And then we have a failed. So this failed record, this couldn't be processed. So the records that couldn't be processed are under failed. Similarly, we have reported. So reported the actual error messages that the surface on the UI. So think of it like a postal system. Record arrives with no addresses. We assign it to a unique address, and then the map sends it back to the delivery confirmation. And I'll just give a quick walkthrough. Just to save the time, I have pasted this piece of code and I'll explain you line by line. So let's go through the code. So we have declared our variables. So we have two variables. Entity, a single sales order record will be processed in the loop, and we have order ID max. This holds the last number from the allocated block which we count up. You notice that there is no use of number range flag, and like most of them use this flag and we are not using it in our tutorial. I have removed it entirely because we'll always use the number range object, and that's a correct approach, and this is a production grade approach which we are using. The next thing we have is an idempotency check. So this is the piece of logic which I have written, and this is an idempotency check, a very fancy phrase, but a very simple idea. If the record is already assigned or already has an order ID, it says don't touch it. This is critical in draft enabled apps where the same record can be processed more than once. We loop through and find the records that already have an ID and pass them straight through mapped, confirming they are already handled. And here we are going to filter our data. So if you see this statements, data entities underscore w order ID, and we are passing the entities over here, and we are deleting the entries where order ID is initially, and there is another check which we have written. So what we do is we copy the full entity list into this WO entities order ID, and then we delete it if there is already a number assigned. And this check statement at the end is a clean exit. Like if every entry already has an ID, there is nothing left to do. We leave the method immediately without any further processing. And here we are calling our method. So this is the method which we are calling, and here we call the SAP standard method for range utility. So this is a standard method which we are using, and we'll use the interval. So this is called the interval, which is 0 1, and this is the object ZNU range. This is the number range object which we have created. That same number range object we have assigned it over here. And the next thing is the quantity. This gives the exact as many numbers as I have as a new record, and SAP reserves a block of sequence numbers and hands it back to the highest number in the block. If something goes wrong, suppose the number range object doesn't exist or the interval has not been defined, then the catch block will be run. We log the errors both reported and failed for every affected record, and then call the return to exit the method completely. If you notice, we are using return and not exit. The reason behind here is exit would only leave the loop or the catch block, but the return exits the entire method that is the correct behavior. And then here we are validating our return code. So this piece of logic is very important. So the number range object calls the return code, telling us that the health of the intervals. And this code, 0 means all good, 1 means last number of the interval just issued. It is a warning but still usable. And 2 means the number range is completely exhausted. So the number range can be exhausted. There is a limit to a number range as well, and it might fail. So if we get 2, we fail every record and return. If you are consistently hitting code 1, that's your signal and to go back to the number range object and extend the interval. Additionally, there is a guard against partial allocation. So I have also added comments. You can go through these as well, and you will find the code as well in my link below. So this is a defensive check, and most of the tutorials skip it entirely. If your number range interval is nearly exhausted, SAP might give you a fewer number range and you asked for. Say that you create 10 orders, but only 6 numbers are remaining in the interval and you get 6 back. So what would happen to the other 4? Without this guard, they silently get no ID and corrupt your data. With this guard, you explicitly fail those records and trim the working list to only the one record that got the numbers. And this is a clean and safe. The next thing which we have done is we are using the number range key. So this is the number range key which we are using, and this is very important. So what this does is the last number is allocated in the block, and then we subtract the returned quantity to get back the value just before the block starts. And then we are assigning the order ID to each new entity. So this is the piece of logic which is written, and this is the final step, and this pays off. For each new record, we increment the counter and assign it to the order ID. So if you notice, we set both of them, entity order ID and entity key order ID. This is important. The percent key structure is what the RAP framework uses to identify the record. So this is very important. If you only set the entity order ID but not the key order ID, the percent key order ID, the key in your mapped append still carries an empty ID, and the framework will lose track of which record got and which number is assigned. Both the lines are required. And then we append confirming the framework. So this record has been successfully numbered. So this is very important. So finally, let's quickly activate our code. If you see, previously we have this order ID as edit field. We'll quickly refresh it and create a new record. So now when I click on create, you notice this is only read only. Test order 1, status as open, say computer, and I hit on create. As soon as I hit on create, an object is created and the number is assigned automatically. If I come back and I click on go, we have a new record for computers, and this ID is generated by our number range object. So now we have implemented internal numbering in our RAP sales order application with proper number range integration, full error handling, partial allocation, and the critical buffering step that prevents the error. I'll also show you what would happen if the configuration is missed. So let's go back to our number range and select no buffering and just save and activate it. So once this is activated, let's go back to our application and refresh it. Now let's try to create one more ID. I'll name it as test2, status as open, order name as test, and amount as 100 US. And as soon as I hit on create, it will give you a dump saying behavior illegal statement. So as I have explained this earlier, the configuration is very important. So this particular configuration is very important. We have to set it as main memory buffering and the buffered numbers as 10. So if this video saved you a few hours of debugging, give it a like. It genuinely helps the channel. If you got any questions, drop them in the comments or reach out on the LinkedIn for the full code. The full code is in the GitHub repo, and I'll give the link in the description. Grab it and follow along and make it your own. Thanks for watching. See you in the next video. Thank you.